help us kind of evaluate the spread as a coefficient of variation. And basically, what it does is it allows us to uh, see kind of how compare the spread to the mean and just see how spread out it is. And if it's a smaller coefficient of variation means it's more concise. A larger one means it's not as concise. So Javier runs a small eight. I'm not sure how to say that in Florida, and it's home to 8 adult scarlet macaws rescued for pet owners that can no longer take care of them. He's interested in how the size of the birds compare to the populations of scarlet macaws in the wild. The tip to tail length of the birds were found to be, there's your links. Compute the CV for the length of the data and explain the meaning of your result. Okay, so what I'm going to do is first, I'm just going to type this into my list. Okay, I'm not going to do this by hand. I'm going to go straight to the list. And so 36.3, you could overwrite these 38.6, 35.4, 34.4, 29.6, 33.3, 31.7, and 34.5. So there's your list there. I'm going to put that in the list, okay? All right. Now, next, before I get too carried away here, the tank that in its population. So population implies we're going to be using this formula right here. These are the population values. S is the sample standard deviation, X bar is the sample mean, sigma is the population standard deviation, and mu, they call that mu. It's a weird looking mu, is this, the population mean. So we're going to be using this formula. This is not difficult, okay? This is not difficult. So all we've got to do is find the value of the standard deviation and find the value of mean and plug it in. So stat calc 1 bar stats, L1. My mean, I know this is confusing. My mean is 34.225. That's my mean. Now that I know that's written as X bar in your calculator, but that is the mean. And since this is all values in this population, that we call that the population mean. Now the question is, do I use sigma or do I use S? In this case, I'm going to use sigma because it's the population. So I'm going to 2.587. So I use sigma there of X, and that's from the calculator. So all I'm doing is plugging in those into this formula here. 2.587 divided by 34.225 times 100. And this will be a percent. I probably should put a squiggly equals here because I'm rounding. All right. So you could do this all at once because it's all equal in the order of operations. Times 34.225. Oh, divided by, my bad. Divided by times 100. And so you get 7.559. So let's round that to one decimal place. 7.6%. Okay. So comment on the meaning of the result. So what basically on this is kind of a good thing. Okay, this is kind of a good thing. We'll talk about this too, like whenever we do the homework. But what this means is this means that the spread is significantly less than the mean. I guess you could say the spread, and this is something we'll talk about in our homework. The spread is less than the mean. Okay, the spread is, I could say, significantly less than the mean. And that's a good thing. That means it's going to be precise. That means it's going to be a good estimate. So, like, why do I say that? The measure of spreads and standard deviation, the measure of mean, you see how that's a lot less than that. And so, if it's great, if you get a value, greater than 100%, that's where you got that's where you kind of run into some trouble. Okay.